Hey, hello everyone. Welcome to iCoding Club. Today we're going to talk about IndexedDB, and this will be a master class on it, so it will be a long tutorial. But we're going to cover each and every part of IndexedDB. We're going to start with very minimal application. I'm going to cover the basic CRUD operation, and slowly we're going to evolve our application into much more complex app with the more functionality of IndexedDB. So this will be an exciting journey. We are going to cover following topic today. We start with the basic introduction. What is IndexedDB? Why we use it? And then we'll start with the to-do app. And first, we're going to explore the native APIs provided by the IndexedDB directly. This will be an event-based mechanism, and it has its pros and cons. That's something we're going to cover it. After that, we're going to evolve our, we're going to kind of put some pattern on the application for accessing the data, and we're going to use a DAO, data access object pattern, to simplify the data access from the IndexedDB. Post that, we're going to use a helper library called IDB after we completed the sufficient portion of IndexedDB the native way, just to understand its architecture and working. And then we will use the help of IDB, which is more like a promised-based API in place of event-based mechanism, event-based API. And we'll see how it simplify our life, what are the advantages it's put on the table, and so on. After that, we're going to cover a little bit of advanced topic like index and cursor. We'll come up with one requirement, and we're trying to solve with index and cursor on our application. And in the last, we can just touch about the some of the IDB wrappers API, which kind of make your life much more easier when you access the IndexedDB. So that's on the table today. Let's start with the the what is the IndexedDB. So IndexedDB is nothing but a low-level API for client-side storage of a significant amount, and this point is important. Unlike local storage and session storage, IndexedDB can store a lot of data, a really lot of data. It's in GBs, depending on which browser you use it. Safari, Firefox, Chrome, you get a different level of data, different level of storage. And we're going to use and the IndexedDB provide you the API which let you do high performance searches on those data. And we will see how we can use the IndexedDB for the sorting and so other purpose. So let's start with the architecture, like how actually it's work. Now IndexedDB in the browser let you create multiple databases. Those are kind of separate segregation of data. You can think about like more like a container which doesn't talk to each other. They are like totally separate one. So you can have something like database for to-dos, to-dos DB, and in the same origin on the same browser, you can have another database called books DB, which holding the books one. And once you have the database, you can have something called object storage. These are equivalent to a table if you have used any RDBMS relation database or even the NoSQL database. It's very similar to that, and it's more like object oriented. So you can put the object data in it and you retrieve it also in the object manner. Apart from the data, since it's almost like a full-fledged database, the IndexedDB, it let you have the indexing on it as well, and then you can have the whole indexing to kind of faster searching on those data. On the data bus, these are the things. One thing, once we start exploring the API, you will see that IndexedDB, whatever you do, database, retrieval, putting the data, it's all under the transaction. Now, transaction, if you worked in other database, let you kind of make the data integrity on your database. But it mostly useful if it is a multi-threaded environment. So how come it's true in the JavaScript, which is a single-thread environment? The fact that JavaScript is a kind of, or the JavaScript in the browser, more correctly, is a pseudo single-threaded system in which on one tab, yes, you do have a single thread, but you can have multiple tabs which result into multiple threads. Even in the same tab, you can have multiple workers which result into thread. So you can definitely have more than n number of threads, right? And the nice part of IndexedDB is that once you create an IndexedDB, you can actually use the same IndexedDB from these different clients as long they are on the same origin. That's the only criteria you need to follow. And since you can access it from the different client, which result into multiple threads, it's important that you put the thread protection when you access the data, or when you more importantly write the data or delete the data. And that's why you have, whenever you access a database at the start, it is something you have a transaction protection or transaction layer, which let you first acquire the table on which you want to acquire the object store on which you want to run the transaction, and then only let you perform the data operations. We're going to talk about transaction in much more detail in the following part, but right now I just want to stop here. On the high level, this is the architecture. Now, before we jump to the code, it's important to understand that how the whole sequencing works when you start a database. Just like any traditional database, it has its own life cycle. Same goes for IndexedDB as well. To start uh, an IndexedDB, you have to first set a request or send a request to open the database. Now, it doesn't open the database directly for you, but in place of that, it let you set up a callbacks on it. So as and when the database is ready, it call those callbacks, and depending on the situation, you either end up in error situation or in success situation. Error is very rare. It's only arise when the user, the browser owner, explicitly deny the access of IndexedDB. Maybe they don't want any data on their browser. But these kind of cases are very rare nowadays with a modern web development. So, but you still have to handle it. So that's why those error callback is there. Interesting part come with the success once you have the connection. Now, IndexedDB will figure out that is it the first time you're creating a database, or there is a version upgrade. Maybe you have added one more indexing or added one more store, right? And in that case, there is a version upgrade. In that case, there are different callback get called. If it is not the first time, then you directly end up in the success and your database is open for access. However, if it is the very first time or there's a version upgrade, it let you fall into something called on upgrade needed, and where you can perform a basic operation like adding, updating, deleting object store, creating indexing, and so on. Once you are done with it, the flow move back to the success callback, and then you can continue as it is. And this is the kind of life cycle of opening our IndexedDB. But what if once you're done with it, the rest of the life cycle? And that's where it's mostly deal with the transaction, which we already kind of discuss in a small manner. Basically, you ask for a transaction, you put a acquire transaction on the store. You either go with the read write operation or read only operation, or the write transaction or the read only transaction. Once you have acquired the store, you can do a CRUD operation on it. Once you're done with it, you release the transaction, and then you are ready to get another transaction. And that's how the whole life cycle of transaction works. This is just the introduction of it. We're going to cover much more detail in the following video. And just before we jump to the coding, let's rephrase or recap the core concept of IndexedDB, so that once we jump to the code, it's much more easy for us to understand it. Number one, IndexedDB is the store of key value pairs. Second is the asynchronous in nature. Unlike the session storage or local storage, which are synchronous and can even kind of temporarily suspend your execution on the normal thread. So this is very important to understand. This is the whole different architecture than the other storage type. Whenever it's all successful, every operation almost in IndexedDB result into a request, which result into callbacks like the success callback or array callbacks. Those callbacks are nothing but events, and that's where the DOM events come into picture. They just work like any other DOM events, means the whole bubbling life cycles, all are present on those as well. You can stop the propagation as well. You can prevent the default way of it and everything. Just work like a normal DOM event. Fourth point is based on the transaction database model. We already cover it in a decent way. So let's skip to the next point. Fifth is high capacity. I was talking about it. You can do in the GBs. In the Chrome and in Chromium browser, you can acquire almost like 60% of your machine's data. That is the laptop or the desktop on which you are working, which is huge data, 250, 300 GB, and so on in that range. And the last one, yes, it's a object oriented, not a relational database. So everything you do it is all object oriented. Unlike local storage and session storage, where you put the data in a string manner, when you get it back, you have to parse it. No, those things doesn't happen in the IndexedDB. You store it as the object, you get it as an object, and you work fully in an object oriented manner. So these are the 6 key characteristics of IndexedDB. Once we jump to the code part, it will be more clear. And the concept, theoretical concept, going to help us once we start writing our code. All right, let's jump to the code now.
All right. So since we have the basic understanding of IndexedDB architecture and its working style, now let's jump to the code to try to understand how it's actually work. We're going to start with we're going to create a kind of a to-do application in this tutorial. And idea to pick a to-do application is simple. That one is requirements are very clear and well known. Second is we required to understand the each and every part of IndexedDB. We required all kind of CRUD operation. And in to-do app, we can do all those all kind of CRUD operation. And that's the reason to pick the to-do app. I have one application in the starting state, something we're going to use as a starting application for this whole tutorial. Before we jump to the IndexedDB part, let's try to understand what we have in this started code. Now, I purposefully kept it very, very simple, very, very minimalistic, so that it's not become a hindrance to start the whole IndexedDB learning part. To see what we have here, let me just start the application. npm start. Our whole application based out of create react app, and I remove the unnecessary file. So all the npm commands of create react app work here. As you can see, when I did the npm start, it opened up the localhost 3000 and our application is up and running. If I just do 1, it just add it and add in the list. If I just do a 2, it just add that in the list. And it's also clear the input. And that's all. That's all what we have to start the application. We will add more and more functionality as the application grow, but for now, this will do. If I talk about the application, it start with to do app. This is the controller file. It's kind of wrap up the whole application. To show what we have here, if we go to the main, we have our 2 main headings, and the main components are to do input and to do table. If we go to do input, we have a simple input which collect the to do text data, and as soon we have it and we kind of click enter, it's kind of called the on submit method, and which eventually get come and end up in the handle submit. What we're doing here is basically we're calling the on submit props and passing the two data, text and completed false. This is like the initial version of that to do. We are not going to use the completed right now, but in later part of the application it will be used. When it's all done, we reset the input to empty string, and that's all. On submit, take our control to handle submit method inside a to do app. If you see here, all we have is basically set to dos, which take the new to do from the input and update the array. As soon we have a to dos, we take it and pass it to dos table. And if we go inside of it, all we have is like, we take the to dos. If the length of to dos is empty or we don't have a to do, we just return it. We don't have to render anything. If we have to dos, what we're going to do, we're just going to iterate over it and build the JSX out of it to display on the UI. For now, I'm just using the index to use in the key, but later on we will figure out how to get an ID of to do. But for now, this will do. Now, since we have the basic understanding of what we have in the starting code, what we're going to do is we start adding the IndexedDB concept one by one. And for that, what we're going to do, we're going to create a new branch, and this is the same branch. We will have it in the GitHub also, which I will share later. We're going to create a new branch out of it. So I'm going to call get checkout -b, and we're going to name it db-native. And the idea here is when we start the IndexedDB, we're going to use the native version APIs provided by the IndexedDB creator. And we're going to build a basic functionality using those native APIs to understand the basic working of IndexedDB and its eventing architecture. But later on, we will move to some kind of helper library. And the reason for that is the native way of native APIs, the way the creator of IndexedDB APIs architecture team, uh, they opted for event-based mechanism. They must be having some reason to do that, but in my understanding and with my opinion, it is very complex and make your application very difficult very soon. But even though it make your life difficult, since it is the native way of working, you need to understand it first, and that's what we're going to do. We're going to build a basic functionality, add, delete, and that's all. And after that, we will just move to some helper library, which is more like kind of a promise-based API in place of event-based API, and that you will soon realize that it's much more easier to kind of work with it. So that's the plan. To start with, we're just going to create a DB native and put all our native based code in this particular branch. Later on, when we move to the helper library, we'll just rename and move to some other branch. All right. So to start with, what we're going to do, we're going to create a folder called DB. And in this folder, we're going to have a file called db.js. Now this file will take care of the basic working of IndexedDB. For example, opening the database, error handling, success case. And as you remember from the introduction part of this video, you also need to create a something called object store, which is nothing but kind of aka equivalent to table in the database in the RDMS or NoSQL world, right? So that's the idea. You can also kind of create something like indexing on those table, but we're going to save it for now. We're going to cover it later part once we reach to the index advanced part. So let's remove it for now. We'll come back to that later. Now let's start our journey. To open IndexedDB, it's part of the window object. So you have to do a Windows, window, and then IndexedDB. And IndexedDB has multiple methods. What we are interested in is the open method. Now open method take two arguments. One is the database name and second is the version. Now DB name is mandatory, version is optional, but we're going to provide both. We're going to call it to do DB, and we're going to have a version 1 to keep this simple. Now if you recall the intro part of this video, most of the APIs IndexedDB based on the event mechanism, and normally they return you on a request object, and the request object let you assign events to kind of take care of different part of it. In this case, what we are interested is basically on error event, which will let us handle the error. So let's put this one first. Second is, so this is error, and then we have the second guy, success, and success is also very simple to understand, is on success event handler. The third, to create an object store and table, this one is a little bit mouthful. It's called on upgrade needed. On upgrade needed is the callback which get called not every time. It get called only when you create the database very first time, or if you change the version. In both the cases, browser understand, okay, you want some kind of structure changes in your database, so it called the upgrade needed, and in that you can kind of can handle these things in action. So we want these all to be there, but we want some kind of utility function which we can use to kind of initialize the database in a single shot. So what we're going to do is we're going to create a utility called DB. Let's create a class, and we will have one static function inside of it, and we're going to call it OpenDB. OpenDB a function, and all these actions what we have here, all we're going to put it inside of it, all three. All right, so let me just clean it up. We don't need it. This is clear now, so let's remove it. So these four is what we are looking for, and we're going to just export it DB, right? And wherever you use this one, we can actually call kind of use the DB initialize to kind of DB OpenDB to kind of initialize the whole database. So let's go over it. One problem we have it is, let's say if we take and try to initialize the or try to open the database, let's say from a to-do application. So most probably you will do it in the to-do app, which is the controller file. And we want it like as soon you kind of mount it very first time, that time we want to do it. So the logical choice of doing that is using the use effect. And the best would be basically you need a DB instance to kind of access it, access the different part of it. We have two method of it. If there are two way to kind of move further. If you see these OpenDB, what I want is as soon the whole initialization over, if we are not in the error, we are on the success case. I want something to be done in the main app file. So one way I have is I can if I follow the mechanism of the DB or IndexedDB. One way is I can pass some kind of callback here, which could be kind of can be called when there is a success, and in that case the rest of the rest of the flow can be moved to the application. But this event-based mechanism is, or the callback-based mechanism is very hard. It's put you into some kind of callback hell, which is very difficult to understand, difficult to debug, and so on. So we are not going to on that direction. What we're going to do is basically want to use it in some kind of promise-based API. So let me just wrap everything inside a new promise. So let's return a new promise from this method, right? And if you're not familiar with the promise API, it basically is very straightforward. Let you kind of chain the callbacks in a much simpler way. So let me just first put it down. The promise API is basically take a callback, and inside that you have a resolve function and you have a reject function, right? And reject is meant for the error and resolve is meant for the success. So let's put this whole code inside of this. And as soon we are in the success, I want to resolve it.
And after resolve, if there's an error, we're going to reject it. So that's the plan. Let's put this all together, right? So remove this guy, call back, and in our to do, basically what we can use now is basically const db equal to await db dot opendb, right? And let's put this whole thing inside a load function equal to sync, right? And reason for putting this whole load function is that it's an anti-pattern to put async into the use effect callback. So that's why I created a separate loading function to do that, to handle the whole async nature of initialization of IndexedDB. Let's come back to the function and let's do the main job. So to error is simple. Let's say new and error. And so when you get the error, basically, when you will go through this error, this is just we're trying to open the database. So the error of you get this error only if, let's say, a user or the browser owner kind of put a restriction of using or opening a data IndexedDB. Only in those cases you will get this error, which is very rare, but you still need to handle it. So let me say no permission to open DB. All right, so that will do. On success, basically we want to resolve and we want to pass the DB database object. So the way it will happen is like these callbacks basically get the event, and inside of event you can have event dot target and dot result. This guy result hold the DB object. So let's call it like a DB, and this DB we can pass it to the resolve method. And that's all it's need to kind of initialize the whole database. Now this will do in most in the all the scenario except the first one, or the when there was an update. For the first one, now you have to make sure that we create the data, create the store in the database. So the way you do it, you pull the database object exactly like this. You put the event here, and in this one DB we have something called create object store. Now create object store take two argument. One is the store name and second is the options. Now the store name would be to do string, and the second would be an option. Now let's take multiple options. For example, what would be your equivalent of primary key if you worked on the basic on the simple database, which will be like uniquely identify the each and every row. So the way that happen is like you have something called a key path, and key path you can define any property of the object which you want to make a primary key. So in this case, we want the ID of to be the primary key or unique identifier. But how you will get the ID? We don't have any logic to create an ID of to do. So there are different way you can create in your application. You can let the delegate it to the server, let server to generate it. But we're going to use a functionality out of box provided by IndexedDB. Just to learn that part also of IndexedDB. In the real world, you may not want to do it, but it's fun to use it to learn this whole concept. And the property of this one is called auto increment. So you put it auto increment and you make it true. So what it does, it like every time a row get created, it just start with ID 1 and then keep on incrementing and just keep putting your ID with every row, right? So that's it, the basic functionality. But the point is you have to understand that none of the API in IndexedDB is so simple like this, right? Everything work in the event mechanism or event modeling. So this is just a request of it, request of creating it. So this particular API going to return you something called store on a store object, and this store only when the whole task is completed, then only the whole object store is ready, and that happen as store dot transaction. Now, if you never work on the database and you don't know the word transaction, don't worry about it. We're going to cover it later in more detail. But you have to understand that the most sophisticated databases let you handle the DB task in a transactional manner. In that case, if multiple threads are accessing it, you don't have to worry about it. So store.transaction on complete. Now, if you're just kind of wondering like how a multi-thread will come into a JavaScript, which is a single-threaded system, don't worry about it. I'm going to cover that part also in detail next. So when that's done, we can just do that. We don't want to do right now any extra things, so we're just going to log it, and we're going to call it store name of the store. So that is to-dos. So let's do one thing. Let's take this guy outside and create a constant, export const to do store, and we can just use it here as well as here. All right, has been created. All right, this will do. Right, so while we are here, let's create two more object. Export db name, export const db version. All right, to do db here, take this guy here. All right, so that's it. Let's see how things goes. We updated it. Let's remove this guy, and on here um, on load use effect, and we have all the pipeline put together. Now let's try to run this whole application. Let's see like where we have reached. So npm start. Looks like we missed something. Uh, Now since our whole application is running, let's come to the browser and see that where we are. Now we have not configured anything around IndexedDB, so that doesn't expect much there. But if we just say 1, 2, the basic part is working. If I refresh it, it goes away. So where is the IndexedDB part altogether? There is no IndexedDB because we have not connected it yet, but we can still see the initialization part of it. So to do that, you have to go to a tab called application. Now in application, you have multiple things, local storage, region storage, as well as IndexedDB. And you can see that we have a to-do DB linked with our origin, and you can see that it has a version 1 and has one object store, which is exactly what we have done. You have also have an option to delete the database, refresh database in case you want to do it. But obviously there is no yeah, there's a store here, but obviously there is no data in that particular store. So it seems like all the things what we have done so far is working fine. Database has been initialized fine. The object store is already there. We can also see that the key path is ID, and all those things are there. Next, what we're going to do is going to add some data into our application as well as going to retrieve it. And for that, we have to understand the whole transaction modeling of IndexedDB in a little bit detail. So let's go to that part first. All right, let's talk about the transaction in the IndexedDB. Now, if you have worked or you're hearing the transaction very first time, transaction is a very common process to access the data in a relational database or in another database as well. Idea of transaction is to make sure that it maintain the data integrity, and normally it's useful when the multiple threads or multiple users are accessing the data in a same time. But in JavaScript world, normally it's a single threaded system. And let's say you have a IndexedDB with the two object store to do and the users and one browser from which user can access it. How come there's a possibility to have two thread, or how can we have a multiple access to this object store? Let's talk about that part first. So IndexedDB, we have to understand is that can on once you create the IndexedDB, it's not linked just to the that particular browser or just that particular tab. Matter of fact, you can have multiple tabs or multiple browsers of same type of browser, and they can access data together. So there's a possibility that there is a one access from here, and then there is another access from here. So for example, maybe this browser can access the to-do store, and then this one can take the user store. We can even have other ways also in which you can have multiple threading. There's two definitely on tabs. You can have n number of tab. You can also have n number of workers, especially the service workers. They can also access this data, and that's how the whole multiple threaded come into picture, and that's why there is a strong need of having the transaction in IndexedDB. Now let's understand what kind of transaction we have it. Now there are two kind of transaction. One is the read transaction and the second is the write transaction. Read transaction normally consider as a kind of a low cost one, because you can have a transaction on a single store, and you can have multiple read transaction in a single store. For example, I can have a read operation from browser B and as well as from the browser 1. So if I put it here, there's no problem with the read. It's all fine. It just work without an issue. The problem arises when there is a read transaction in the picture. For example, let's say if there is a worker, or for the discussion, let's just continue or kind of just limit the discussion to the tabs only. So you have the third tab, and from that tab, there is a write transaction. What happened to make sure the data integrity is is correct? IndexedDB for a temporary basis, while there's a write transaction, kind of stop or suspend the read transaction as well. So while the write transaction is stored, or while the transaction acquire the to-do store for the write, you cannot do a read transaction, and these are not allowed. And that's there the problem come into picture, that you have to make sure that you minimize the number of write transaction in your system. For example, if you have the one write transaction, because in the transaction you can acquire more than one object store. And in case you're creating a to-dos and you add the to-do store, as well as you're creating a user store where you're counting the number of to-dos, active to-dos for a user. In that case, you have to update both the store, and in that case, you will require a transaction on both the store, right? And in this case, you will end up putting the kind of a lock on both the store. And while those locks are there, there is no read, no other reads are possible. So this browser has to wait. And if they are service worker, they also need to wait. And that's where the whole concept of transaction should be very, very clear while you're using the IndexedDB. All right, let's see next as in the code how we actually use a transaction. Right. Since we have the basic understanding of transaction, let's try to put it in action in the code. What we're going to do next is we're going to utilize the concept of transaction, and we're going to do two transactions in our code. One is to write the to-do in the IndexedDB, and second is to read it. Write, as I expect, it is the write transaction one, and second would be the read one. So there are two different type of transaction we're going to use it. Now if you see, go back to our application into the component, and this is the place where we actually get the to-do and we put it into our state. Now what we're going to do is we're going to get the DB first, and then we're going to kind of write it down right in DB, right? So those two things what we're going to do. We already covered the our utility function. The way it work is like you use promise-based API to kind of get the database. And since it's a async operation, let's put async here. Sorry about it. Async, and now we have the DB instance of it. Now transaction is get created with the DB instance, so that's why it was needed. Now the way it work is like, the DB has this transaction function which take two argument. One is the number of object store on which you want to acquire the transaction, and second is the right type of transaction you want to do it. The second option is by default read. Only if you need a write operation, then you have to provide it. So the first option could be an array, and you can put your store name here or an object store here. So object store, if you go back to our DB, we kind of exported that name under the to do underscore store property. So what we can do it here, we can just pull it here and then put it here. In that case, it will kind of acquire the transaction on the to do store. And what we need is basically a read write based or read write transaction, right? So we can put it as a second argument. And what this will do is basically going to return you an kind of a transaction object by which you can actually pull the data. And to do that, what you need is you have to provide the store name from which you need the data. So for that, you have something called object store, and then you provide the name of that object store to get the data. Now let's make sense of this line one more time. First, you put all the store on which you need a transaction. So this could be more than one. So to do store, user store, and so on. And then in the second part, you put the name of store from which you want to fetch the data, and that's how the whole thing works. This particular line doesn't give you data back. This give you a request back, just like any other IndexedDB API is also based on the event mechanism. So what you need to do, or basically this return you the store object, right? And then from the store object, you can actually do a kind of operation. So in this case, we want to add and to do, and this will basically going to give you the request object, right? So I was just kind of moved a little bit ahead. So in this one, what we want is to do. I just put it here and const request. Right, so this is our guy, the request, and then this going to provide us the data as and when the event is done. So to do that, what we do is request dot on success. So though it's event-based mechanism, a little bit pain, One thing good about is like the structure is kind of common between all the requests. Either you open a database or you open a simple database object store request. So always be on success, on error, and so on, right? So to get the data from in the on success, what we can do, you can say request dot now this statement will give you a to do. So if you put it like to do equal to request result, but this will be a special to do. The special in the sense that it will have the ID put together, the auto incremented ID. Because if you remember, when we initialized the store, we made it like auto increment equal to true. So let's call it to do DB. And what we're going to do is we're going to just store this database, this to do into our state. So we have our set to dos at the top. So let's call it set to dos. We're going to use the function version of it to make sure that we get the updated to dos in the state, and we get this one and to dos, and then we will just add this new guy in the town at the end, and this should do the job. What we can do also here, we can log this guy so that we can just inspect a little bit. Let me just use it here. Now let's come back to our application to see that if it's all working fine or not. So let me first the first to do one and then two. So at least our application is working fine, no issue at all. Now let's go to our store to do this, and if I just open up this, right? So we can see that our to-do is already put together in our IndexedDB database. So if you see here, one completed false with ID 1 and this thing. So the text is coming fine, the ID is coming fine, it's all perfect. If you go back to console, this is our printed one. So you can see that it's also printing correctly. So awesome, right? So it's working fine, the exactly the way we expected. We managed to successfully able to put it. Now, if you refresh it this time, we don't get anything. It's very clear because we are not loading the to-dos. So we're going to do that part next. Come back to the code. We already have our DB here. We can copy this whole line, put it here. We don't need a write operation, so remove that guy. And by default, to put it again, it is read transaction. So now we have the read part of it. So to get the data, what you do is basically you kind of say to do's. Oh, sorry. Um, to get this data, what you need is store dot get all, and this will give you all the data what you have in your database. Definitely, you can provide some kind of query in get all function, which will kind of help you filter down the to-dos, but that is to advanced part of this lecture. Now get all again doesn't give you the data directly, it gives you a request object. And with the request object, again, you have to wait for a success. So let's copy this whole part of it and here. Now again, request dot result will give you to dos because it's a all to dos, so we put it, and then we don't need the whole thing. We can set it directly. All right, to dos db to dos. db to dos. All right, let's go back. Let's refresh. You can see already working. 3 and refresh it, and we can see 3 is coming, but do we have? Yes, our third is also coming. Now let's copy this, open a new tab, close this guy, open it, and we have all our three to-dos here. No problem at all. To database has all our to-dos working just fine as expected. So that's covered the basic part of it, how you get the data, how you put the data, how you put the transaction. Next, what we're going to do is we're going to put some kind of pattern to our code. You can see that it's like right now seems like all the things we are doing in the component. So we're going to put some pattern which will be like kind of best practice to fetch the data from the IndexedDB, and that part we're going to talk next. So since now we have the basic working code, it's working fine. We are able to put the data in IndexedDB, and we are also able to get the data back from the IndexedDB. Now we just have one problem left. This code is not scalable. If you see here, I'm getting the DB instances. I'm trying to get the DB instances in both the places, getting the transaction, putting it right. So a lot of things are exposed here um, in this particular component file, in the UI component file, which is not the right thing to do. This is data related code, so it should be in separate file. So we're going to do that part next. And we're going to use a pattern called DAO pattern, data access object pattern. Now DAO pattern is very common way to kind of simplify the data access by putting all the data access related logic into a separate file. So we're going to do that next. Let's create a DAO folder in the DB, and let's call it to DAO. So DAO to do DAO.js. Now this DAO file will be a singleton object. Um, so let's create a to-do DAO because we don't need a frequent creation of this object. But we still may require a constructor object in future. So what we're going to do is we're not going to create a static function based class. We're just going to make it a singleton object. And a very simple way to kind of achieve that part in JavaScript is you just create an instance to do DAO equal to new to do DAO, and we just export it default to do DAO. The one advantage this pattern gives you over the having a static function in a class is in case you want to initialize it with some parameter in a prod environment, in pre-prod environment, those things are possible since we are using a object, singleton object. So let's come back to the DO file, DO class, and few function what we required here is add that to add a to do, and then get all, and this is basically we have been using it, and we will also require one more function that is get. So we come to this later, and this will take a key, and add will take a to do, which we're going to put in the database. So let's start with the add part first. Let's come back here. Our add logic is here, right? So what we're going to do, we're going to take this whole logic and put it in my to do function. Now we again have a similar problem that how you're going to communicate the component back that you already achieved or already received, or you're done with the whole to do part. Again, the one option is pass a callback, which will work more like an event mechanism. And the second option is what we have been using so far, that is a promise-based method. So we're going to continue on our promise-based API. So let's return it, create a new promise, and as usual, um, not this one, promise, and callback, resolve, and reject. Right? So we're going to copy this whole thing inside, and we we need request.onSuccess, and on the resolve here, to do here, what we need to put the object. Right, so let's remove this much, right? And this will not be a to do and from DB, it would be a to do key, right? So what we need basically is a way to get the to do back. A request.result is actually doesn't return you a to do object, is actually return you a key, which what just newly created key for the to do or the newly added object in the object store, right? So we need to get a to do back from this to do key. So what we can do, we can utilize our get method what we have created at the downside. So to do key, and so we come to this part later. Again, I guess before we finish this part, we need to kind of finish the get part first. So let's copy this whole thing, put it here, and we need a async function. So this is done, resolved, read write. We don't need read write. To do store, this is fine, and what we need is store dot get key, and this will again give a request, and once we have the request result, this will be our actual to do DB, right? So what we can do, we can resolve it with our to do. All right, so this seems fine. Now we should be able to kind of get it here in the using this get one. Now we have one problem. Again, we need a sync here as well. Now we cannot use async await here. This is also a kind of promise-based function. Since it's inside a promise constructor, async await is not allowed here. So we have to fall back to the older way of getting the data from the promise, that is a then based object. So on this one, we're going to get to do db, and then callback will return you your data, which we finally can resolve. So resolve to do db. Nice. I guess to do store I haven't imported. Okay. So we need, okay, db, right, and to do store. All right, let's see this thing. To do app, we have add, we kind of do the transaction, read write, that makes sense. We just added it, we got the request objects on success. Once it's done, we got the key back. We pass this to the get method and get the whole data back, and then we resolved it. And here we are in get, object store, store get, and seems like it's all done. Now let's come back to the component. We don't need such a complex logics. Let's comment it out. We just need our to do do now, to do do, and we need add. And in this guy, we're going to add our to do. This will return me to do db equal to await, and then we can use this code to connect the whole thing together. Let's go back to our application just to see that it's working or not. So let's do a npm start. We have some previous data, so let's clean it first. Delete database, refresh it, and all new and fresh. Start with 1. Seems like we're getting 2. uh, yeah, okay, we left this guy here.
2, 3. All right, seems like all working fine with our new DO pattern. 1, 2, 3, perfect, right? Now we done with the DB entry part or putting the date to do with the DO pattern. Now let's repeat the same thing for to get data as well, right? So we can come here. We can come to the get all. Let's mark it async. We are good with here. Read write, we don't need it. It's a read operation. Remove this guy. Store get all with no data. We got a request to do result, and we can resolve this guy. To dos. Yep, seems like all what we needed. Let's come back here in the load. Let's comment it out, all the things to do. Not get all will give us the to dos. So const to dos go to await, and we have all the to dos with us. So let's set it up to the state and delete this much. Seems like all working fine. 4, 5. Move to the next tab. All 5. Perfect. So seems like all is working fine. One last touch up I wanted to do in this particular file is basically, if you see this one, that we have our operation that read write. Now this also kind of can be exported from our DBJS, not like a mandatory, but something could be a good touch export. Const operations, or let's call it transaction write to read write. We can come back here, pull this operation, and in that case it's all kind of just nice and clean code. Transaction not fine. Okay, I haven't saved it. All right, so let me just do it. 5, 6 seems like all working fine. All right, so that's all I wanted to cover in part in the native version of it. So in the next part of this tutorial, what we're going to do, we're going to replace this native code with a helper library, and we'll talk about that later when we reach to that part. All right, see you there. So now we are at the end of the native IndexedDB code version of tutorial. We're going to start with the helper library IDB very soon next, but before we jump to that part, let's recap what we have covered so far. So we started with the basic React component, and then we created a db.js file to initialize the database. We kind of soon learned that the event-based mechanism or event-based API of IndexedDB native is a little bit hard to kind of handle it, and that's why we kind of wrap it up with a promise. And this whole thing we kind of initialize in the to-do app. And once that is done, we first try to put the data in IndexedDB in the UI component, and later on adopt it for DO pattern, which makes our logic much more simpler. So what we're going to do next is we're going to introduce an IDB. This is the one helper library, very famous helper library, which do a kind of which decided to kind of modify the or kind of create a wrapper over the IndexedDB API and provided a promised based way of handling IndexedDB. Is very much like what we have done so far. And once we start using it, you will realize that the whole promise based API or the approach what we took come very handy when we move to IDB. So what is IDB? So to get that one, that library, you just have to say GitHub and IDB, and that will open up your the GitHub page of the library. Now you can already see that it's a very popular one with a very high number of stars, 5.3, and it's very famous among the people who are using the IndexedDB on a regular basis. The main difference here is that it still use most of the way you use IndexedDB, like object store and so on, but it try to kind of wrap it up, provide some kind of promise instance so that you can easily kind of work with it. So to do that, what we're going to do is we start with the installation. So let's go back to our code base and let's write npm install IDB. And once that done, yeah, one more thing we also want to do is basically we are in the still on the DB native branch. So before we move to anything further, let's try to move to a different branch, and we're going to call it DB IDB. Uh, Get checkout -b. All right, so we are on the IDB branch. We already have our package JSON updated with the IDB library. So let's continue. So we start with the db.js, and there are few changes on initialization of DB, initialization of IndexedDB, and as well as how you get the data back. That is in the DO layer. So we'll go and update it one by one. Let's start with first importing the IDB. So we go at the very top, and we're going to call it import from IDB. And to start with, it's IDB exposed on multiple API, multiple module which you can use it. In this case, we just interested on OpenDB. Now, OpenDB let you open the database, but in much more concise and clear way. So I'm going to show you next that how that does. So we will go come to the OpenDB, and since we named our function as OpenDB as well, it may create some problems. So in place of importing as a named parameter, just let's import it as a utility or as a whole file. So I'm just going to get star IDB, and here we come and say IDB dot OpenDB. Now the Open Database or IndexedDB basically take two parameters, just like the native version of Open API. So we're going to take these two and put it here. But it also takes the third parameter. The third parameter is basically the configuration, what you're going to provide. Now it let you kind of provide multiple callbacks to handle different status or different state of IndexedDB. The most what we are interested is the on upgrade needed version of it, that is upgrade. But similar to that, we have the other function also exposed. So I'm just going to call it. Now upgrade gets a multiple parameter. What we are interested on is the very first one, that is the DB. And we're going to take care of exactly same thing what we did on the native version of on upgrade needed. So what we want to do is to kind of initialize the object store. So let's take this whole code and put it there. All right, so we have the store, and we can put the same message there as well. In that case, it will be more or less same, right? And that's all kind of what we need to initialize it. In previous version, on the success, it's give you a callback which you can resolve to return the DB instance. But in this case, since it's a promise-based API, it return you it directly. So we can just directly call it like constant DB equal to await IDB and async, and that will kind of um, give us the DB instance directly. So we can kind of delete the whole thing. So we kind of good there. In our case, we just basically want it to return it back directly, so that in our controller component to do app, we can kind of wait for it and to initialize it. So in place of getting the instance here directly, what we can do, we can just return it, and that will do, right? And we will do await the place where we're going to call it. And since there's no await here, we can remove the async as well. So you can clearly see that our code is much more cleaner now, and it has nice, much more elegant API to kind of handle the different callbacks or the life cycle of IndexedDB, right? So I guess that's all what we need to initialize it. Let's see, like, if we manage to initialize the database or not. So I'm just going to start our application. So npm start. We already, our application is up and running. What I'm going to do now, first, I'm going to delete our database just to start fresh now. So let's refresh it. And once we refresh it, we can clearly see that our database got created. We already have our object store here, and it's also created, you know, our object store as well, and we got a database as well, right? Obviously, we don't have any data here, but the basic part of once we created the object store, we provided that the key path is an ID. So that part is taken care already, and it says that key path is ID. Now let's try to add something here and see that if that is working. So if I say 1, seems like it's not refreshing it. So there is something we have to do, right? So let me just see if we have the data. And we can see that the data is coming to the database, but not our application is not refreshing in a correct way. So there are part which is where the IDB and the native IndexedDB kind of overlap, and those things work always without further much modification. But then there are part where it doesn't overlap, and those normally break. In this case, the adding part kind of overlaps, so that's why it's working fine. But what we're going to do, we're going to make our code much more IDB friendly and IDB compliant. So the next part, what we're going to do, we're done with our initialization. Let's go to do do and try to modify this whole code. So what we're going to do first, we're going to modify the add part of it, the whole add logic, and to do that, we already have our DB instance put here, so no need of any further things. After that, what we can do, we can just try to pull the store, and for that, we can actually copy the whole logic here. And just like previous way, we can actually put our to do, and in that case we can use the add function and add the to do. So far it's fine, it's kind of work exactly like native code, but here things will start, it will kind of start at different thing. So in place of providing a request on which you can run the callback, it just let you use the promise API and return you the value directly. So in this case, what we are expecting here is the to do key. So I can kind of take this whole code and delete it. And once we have that part, so we have the already to do key. Mind it, it's just a key of newly created to do. It doesn't give you the value. So what we can do is basically return. We can ask store to give the actual to do,
And for that, what we can do is store.get, and as a parameter, we can provide a to-do key. That's what all we need in case of add. And while we are here, let's modify the get all as well and see if that works. So we are fine till here. We can take the store code as well here. And in place of getting the request, get all will just get the to-dos, and we have to await it for that. But the place where we are actually calling this method, we are already awaiting it. So in place of doing this, we can just do a return, and that will do the job. So that is also done. Though we don't need a get right now, let's modify this as well, just to keep the everything to, in the same manner. So let's copy the whole thing. We don't need a write transaction, so remove that guy, and store.get and key. And that's all what we need. You can clearly see that our code is much more cleaner, much more concise, and much more easy to reason about. So let's see that if it is really working. So I reach to the code. Let's refresh it. I can clearly see that the get all part is working fine because we already have the to do pulled in. Let me create the next to do. Nice. It's getting added, getting pulled here. 3. Seems like it's all working fine. Let's refresh our IndexedDB and see that if that is also showing. And we can clearly see that it's all working fine. Now, while we are here, there's one more thing we can do to kind of make our code correct is come back to to-do table. And if you remember, for iteration, we were using index as a key earlier, but we don't need it now since we already have the ID which is generated by IndexedDB. So let's put that ID here, remove the index, put our guy back here, refresh it, all fine, working fine. Let's open up another tab, close all. Perfect. So it seems like it's all working. And if you notice, we haven't done any changes to our component. To do app, we didn't touch it. To do input, we didn't touch it. We could have left the to do table as well, but just to pull the ID, we kind of touched it. And frankly, just two places is basically where we modify our code, that is initialization as well as the DO layer, and that's all. And that's how we kept our code completely separated to each other. So this is the basic version of IDB where we can do a get and add and get. Now we'll move further and kind of extend our to-do app with more functionality. The next would be the delete functionality. So let's cover that in the next part. So now since we have understand the basic of IDB as well, how to add data in IndexedDB, how to get back from IndexedDB, now it's time to put focus back on our application. Now you will see our application right now. It is very simple and has a bare minimum. Obviously, that's for reason to make things simple and easy to understand. But now it's time to extend it further. So next feature what we're going to add in this application is the option to delete and to do. And we're going to have some kind of hover button here on which once you click on it, it will delete the to do. So let's do that part. Let's go back to our code. First, we're going to create the UI component, and then we come back to the database part of it. So right now, here we render our to do and we just display the text. But to make it scalable, it will be nice to kind of move the whole thing into a separate component, and we're going to call it a to do item. So let's create a to do item dot .jsx. Let's create it. And in this one, the props what we're going to get is the to do, and we're going to display it as text. Let's have it um, inside a span. All right, let's first get the text as well. So we just restructure the text, and that's kind of the basic part of it, of displaying the text. Now let's add a button here which can help us to delete this to do. So let's create a button, and we just keep it simple. Just put a cross X here, which once click on it, let us delete it. So to delete it, what we're going to do is on click, right, on click, we're going to have on click, we're just going to have on delete, and this on delete, what we want is basically take an ID which we'll use to delete it. How are we going to get the ID? So inside to do we already have the ID, so let's pull that as well, and all delete, let's have ID. Now let's take this part as a part of props, so alongside our to do we will have on delete as well. Let's clean it up, and if this is the to do item, so this whole on delete need to be passed from the table. So we come here, we don't want to handle the whole delete part here, we just want to handle the whole thing into the to do app, because that's more like a kind of controller component for us to handle all the business logic. So here let's just kind of pull our to do item. So in place of text, just get the to do item, and to do item, oops, something wrong. All right, so we are good now. So let's just pass that to do, and in place of doing the destructuring, now let's just get the to do directly, and ID, we can do to do dot ID, and here we can just pass it as a props. Next props will be on delete. So on delete, and this is, we're not going to do anything, so just going to take the props from the parent. So this component will work more like kind of just a pipe to pass this on delete props. Let's come to the to do item, where finally we're going to handle the on delete. So let's create a function called handle to do delete. Keep handle to do delete, and this guy is take an ID as a parameter. So what we're going to do here is delete the to do, then fetch the fresh to dos from DB. So let's do that part one by one. So to delete it, what we can do, we can have a do function like to do do and delete. Definitely we don't have it right now. We're going to create this function next after that. This will be the next addition to the DO layer. So for await, just put the async here. Once the whole delete part is done with the help of ID, what we want to do is we basically want to pull all the to-dos. So I will just say const to-dos equal to await to do down and get all, and this will get us all the to-dos. And next what we have to do is basically set in the state. So set to-dos, all good. So in case if you manage to delete it properly, it will kind of take care of the all job. So let's do um, the missing piece. Let's try to implement this delete function in the DO layer. Let's come to DO and sync delete, and we will delete with the help of ID. Come here, and to delete it is a write transaction. So let's pull the one example of write. So now we have the write transaction with us and we have the store with us. So just return store dot delete and then just put this ID. In that case, you will get the store within the transaction and delete it. As soon that is done, we'll kind of return back to the our whole as to the our component. And since we are awaiting here, it will make sure that the whole transaction is over. Once that delete is done, we're just going to fresh it, going to get a pull, going to pull the latest data. In the real scenario, you also should be handling the error scenario, error cases, but right now we're just skipping it to just to keep it clear. Let's go back to our application and just see that how it looks like. We can clearly say that already our button is showing here, and though it doesn't look like nice. So we go to our application and try to delete our to do. So I'm going to click on 3. So in case if it is deleted, we should have only 2 to dos, which is right. If I delete one more, refresh it, just one, and if I just kind of refresh the browser, I'm still have just one, right? Let me just add one more, 2, 3. It's all working fine. So we can clearly see that the whole delete part is working fine. Now we can move further, but before that, this whole part looking a little bit ugly. So let's do a little bit digress a little bit and try to add a little bit of styling here. So what I'm going to do, not anything fancy, we're just going to keep it simple. So let's create a to-do item and put this guy into to-do item and class to-do item, right? And what we want is to this to be displayed as flex, and we want this whole text and button to be separated out completely. We want this button to be the rightmost side. So to do that, what we can do a justification content, that is justify content, and we can just say space between. That will make sure that it's all kind of move aside. Let's see that. All right, that's nice. Next is this button doesn't look that nice to me. So what we can do, we can have normally you don't have the border and the background on the close icon. So to do that, let's have to do item, and we will say border none, and we're going to say background white will do for now, and this will do the job of removing the whole thing. One last thing left is okay, it's also not showing the cursor, so let's say pointer, sorry, um, is cursor pointer. Perfect. So yeah, that's nice. And one last thing we can do it like, it doesn't make sense. Or we can leave it here as well, like in case you like the close button always. But in case you want it to be a little bit hidden so that nobody accidentally click on it, we can do that only on the hover of row, that particular button is visible. So the way we can do it, like we can have to do button, and by default we can say display none, and here we can say display block, but we want to do it only when somebody hover on the row. So let's say since we have only one table, we can put a styling on tr and say hover, and when that happen we just want to display it. So right now by default doesn't show up. If we hover on the row, it's kind of show up. If I click on it, it just work as expected. 6. Nice. Refresh it. All working fine. Refresh the IndexedDB. We have only 6 here and nothing else. Perfect. So seems like delete is all working fine. In the next part, we'll move to the next functionality. We are done with adding our first functionality, that is deleting to do. Um, let's move to the next part where we let a to do to be marked as completed. And the way we're going to do is we're going to have a checkbox here before each and every to do. And if you click on the to do, it will strike through that particular to do for the visual experience. If you unchecked it, it will put it back in original state. In the background, what will happen that in to do we have a property called completed. So we're going to kind of toggle it to true and false. So that's the plan. So again, let's start with the component first. So we are here at to do item, and we want to add a kind of a checkbox here, right? So what we're going to do is um, I'm going to create input of type checkbox. All right, and let's kind of group this together inside a section. So this whole thing will be here inside a section. We kind of put together for to do as well as the checkbox, and the action, the delete action will be separate. Let's do a little bit of formatting so that it's just easy to understand. All right, this is much better. Okay, there's spelling mistake here. Checkbox. Now let's go back to the UI and see how it looks like. Okay, we have the checkbox, but our UI is totally broken. So let's fix that. Um, so it is under the to do item and it is a section. So let's go to the style again. So idea here is not to go too much in styling. Just put a minimum style possible so that it doesn't look super ugly on the UI. So to do item section, and we will have it display flex and justify it flex start. We want all to be left aligned, so that's why we are putting as flex start. And though not needed, we will just kind of make it vertically center. So align item center. It will helpful in future. Let's looks like how, so yeah. So this is nice. Looks like what we want. There's just too much. The checkbox and the text is too close. So let's fix that quickly. Section, and we want a little bit of gap between the flex item. So maybe a 0.5 rem. This will do. Okay, perfect. So it looks like what we want. Now let's go back and try to add the actual logic uh, around updating the IndexedDB with the status. So we listen for on change event to listen for that toggling thing, check and uncheck. So on change, we want to call a function. Let's call it on to do update. And on this one, what we want to do is we want to pass an a to-do object. So we'll keep everything as it is. Whatever we get into do, that is ID and the text. And with just the completed part, we're going to toggle it. So let's pull this part first. Completed. And we will just call it completed and the other value. All right, so let's pull it from the props. It's kind of done. Just to make this whole thing as a control component, so let's put this as a checked value. So checked, we want it to be checked if it is completed. So this will do. So on to do update, let's kind of do a pipeline thing on the to do table. Uh, Nothing special here. Let's connect the props. Put from here on to do update, and this is the place where we want to kind of put our most of the logic. So on to do update. Now on to do update, we're going to call it like handle to do update. Handle to do update, and inside this we're going to get our to do the updated one back. Now to do that, to update the IndexedDB, what we can do, we can create just like delete, we can create one more method, and we're going to call it update, and we're going to pass it this to do inside of it. Alright, so if this one successfully passed, let's put the async here to get rid of that error. Now, if it's all work fine, it will update the IndexedDB once we connect the to-do part, the DO layer part. But to update the UI, there are two options. Either you get the updated to-do, do run a for loop, find out which one is which to-do is changed, and depending on that, you update the to-dos uh, uh, accordingly. But to keep things simple, what we're going to do, we just avoid that complex logic, and in place of that, we're just going to pull all the to-dos freshly from the IndexedDB. That include the completed one, and in that case, we just update the whole state together, right? So it may be a okay choice, right? But you have to evaluate which one work better in your use case. I think both solutions are fine. Either you update the state with the updated to-do, or you just pull all the data and update the all to-dos. Now let's go back and update, provide this update functionality into a DO layer. So we come here again, saying update. What we get as part of it is to do. And in this case, we need a write transaction. So let's put it here. And so we have write transaction and we have the to-do store. In place of delete, we're going to do a put, and put actually take a to-do or the object which you want to update it. It's optional, take the ID also, which one you want to modify it. That is the key property, but in this case, we don't require it. So it will just take this to do, pull the ID property from it, and going to update the that particular to in the IndexedDB. So technically, it's all done. Let's see it's actually working. Let's go back to our application. We're going to start it fresh. So delete the database. 1, 2, 3. Let's try to modify this guy. And if we update it and just go and see in this one, we can actually see that it's been updated. So if you see the 1 and completed true and rest are false. If I update this other guy as well, refresh it, Now both 1 and 2 are completed and the third is false. So this is good, but on the UI we are not getting any visual indication. So let's fix that quickly using some styling. So go back to do item, and what we're going to do here, we're going to create one property. We're going to call it text decoration, and if it is completed, then we're going to pass a property called line through. Now this is a CSS style property on the text CSS value on the line text decoration property. So let's call it like line through. Hopefully spelling is correct. Yes, it is. And if it is completed, strike through. Otherwise, just leave it as empty. And we can put it here inside our text here. So we're going to create a style, inline style property, put another object, put our text decoration. Let's do a little bit of formatting. Come back on the UI. You can see already is done because it's already pulling from our IndexedDB. Let's uncheck it, and it's all working fine here. Refresh it. It's again went back to completed equal to false. If I clean it, click it here, refresh it. This all good, right? Same thing. If I refresh it, all three are true. And let's verify that our delete is working. Yes, it is working. And as usual, let's move to the next tab to make sure that there's no cache as per se, and it's all coming from IndexedDB. So perfect. So seems like our update part is also working. So in the next part of the tutorial, we're going to cover something else. So I will see you there. In this part of tutorial, we're going to enhance our application in a full-fledged to-do application. And in the process, we're going to cover two very important concepts of IndexedDB. Those are, the first one is the indexing, and second is the cursor. So before we go to the requirements part of it, like what we're going to enhance in the application, let's understand what are the index, what is the index, and what is the cursor. So let's understand this whole part as one example. So we have four to-do records in our application with ID 1, 2201, and we have put one label. We haven't introduced it, but assume that you have a label here in the object with a priority P0. And same way you have another to-do with priority P1. In third one, we just repeat the priority, that is the P1, and in fourth, we don't have it. Now, what if you want to find all the to-do with the priority P1? That is this one and this one. How are you going to do it? Of course, one way is that you get all the to-dos and then iterate in your code and try to find it out. Now that would be good for, let's say, the 4 record, but once you start increasing it, let's say 1,000 or 10,000, it may not be a scalable solution. IndexedDB, since it works almost like a full-fledged NoSQL DB, let you solve this problem in an elegant way. And that's what we call indexing. So in that case, you can have more than one indexing on your object store on different properties. So you can have on the text, you can have on the label, you can even have on the ID, but that may not serve any purpose because we already have the indexing on that. So how it actually work? Assume that we have this record. So in case uh, if you try to put the indexing on the label, what IndexedDB will do is it start with the first one when you start putting the data. Is look for the label P0 and try to see like, okay, it's a unique one, so let's put it. So it will create a object store. Mind it, this is also an object store, and it will create a new object store for this object store. So object store to map an object store. And with the key P0, that is the value of label, it will try to have a lookup value. And what could be the best lookup than the ID? So it will going to store that ID value here. Idea here is that when you do a lookup, it should be O1 operation, that it should be as fast as possible. And that's why a primary key or the key value of the object is the ideally suited for that. Now let's move to the second record. We see that there is another label with a P1 which is different than the previous one. So let's IndexedDB will put one more entry P1 with an ID 2. Move further. Again we got a P1, so it's a repeat. So it will see that okay, I have a repeat, so let's add that one an array. So it will just add that value as a 2 comma 3 in an array. It come to the fourth one and it sees that there is a no label, so it will just going to skip it. And that's how its whole thing work. In this case, you have the value corresponding to from this one, you have corresponding to this. Um, just one second, I delete this one. Okay, right. And this will go for this one, and this will be for the two and the third. And this is how the whole indexing part works. So that's good. This is the one concept we wanted to cover, that is the indexing. You can have for more, as I mentioned earlier, you can have for more than one label. So if you have for more than one property, you have a label, then that's there. If you have completed, non-completed, on that also you can have it. Second concept is the cursor. So cursor is nothing but it's kind of a pointer on your record. It's let you iterate over it. So when you do a get all, you basically get all the data, but you don't get a chance to iterate over it. What if you want to iterate over those record? What you have in the IndexedDB. So cursor let you do that. You start with first, you go for the second, then you go for the third. As you call the continue, it will go for the fourth one. So it goes one by one, one by one. Every time you call the continue, it moves to the next one. But the best part of the cursor is that it takes multiple configuration value and it can change its behavior depending on what you pass. So this was the forward cursor. You can also go another way around, backward. And third option is that you can also go to the unique value. So in case you run a cursor on the unique on a property, you can always find okay, where is the next unique value? And in that case, it can clearly jump on the next unique value. So these are different configuration you have when you go in the direction part of it. Also kind of limit your cursor movement. You can have the maximum value of a data and the lower value of data. So you can have a kind of subset of all the data and just run the cursor over it. So those all flexibilities are there, and we're going to cover that in this part of this tutorial. Now let's go to the requirement part of it, like what exactly we are trying to build and how we're going to learn both indexing and the cursor knowledge. So far what we have been done, we let people to add to-dos, but in this case we're going to let people add to-do with a priority, what priority you wanted. And to do that, what you have to do, you have to put a hash and then you can put a like a p0 or whatever priority you like it. And matter of fact, you can put any label, whatever you like. And in that case, it should be get added as the label property on the record. And of course that this thing is not there, so we're going to build it next. But before we build it, we will put some constraint just to keep this whole part a little bit simple. In the real world, it could be a little bit complex, but in our case, the constraint would be that any label you want to put it has to start with a hash, and it should be the end of your to do. So you cannot put the label in between. You cannot put the text after the label. No, that's not allowed. You have to put the label at the end. And it will just kind of make our life a little bit simpler. All right, so that's the requirement. Let's start building the UI first, and then we will connect to the IndexedDB. So to do that, let's start with to input. And what we're going to do is every time a submit happen, we're going to check like, do we have uh, a hash in the value? So to do that, what we need is if statement, and to do is our text. So we're going to say to do includes, and if include hash, then we are interested in kind of extracting the label in that. So to do that, what we can do, we can use the split. So we can to have a text as a first value and the label as a second value, and we're going to split the to do with hash value. And if it is there, then what we want to do is we want to submit it a little bit differently. So text would be text, and we want to add one more uh, property, that is label, and completed will be remain false. That's not a problem. And we will just have one more else section here, and this behavior will go here. And once all done, we will just set clear the to do value. So this will kind of going to split it and going to add the label on it. Now let's verify that if all is working fine. So let's start the server. npm start, and we came here. Let's first clear up the whole database so that it just kind of work from the fresh database, right? And we're just going to refresh it. It's all been nice and clear. Let's try first putting a priority. So if I put it P0, nice. We can see that splitting is working, and we got the to-do value, and that the label has taken out. We will see that it's really working or not by looking in the database in a second. But let's add one more. We will put P1. Third, we will put P P1, and to the 4, we don't want any label, so we leave it as it is. Let's check in the database that is it working fine or not. Right, so if you see here, um, if I expand the first value, we can see that the label is coming as P0, P1, P1, and in this there is no label. So it seems like all the label splitting part is working fine, and that's kind of uh, cover the UI part of it. Now let's start putting the indexing logic in our database. So indexing actually work when you initialize the database. So when you initialize it, it goes to the upgrade, and in that upgrade you can actually create the indexing. So to create an indexing, what you need is basically you have to take the store, and then you have to call something called create index, and you can provide any name to indexing, but it would be nice if you just prefix with index so that is just clear. And second could be the property in which you want to put the indexing. So if I just put label, that will do. It is the name of the indexing. The second would be the property on which you want to put the indexing. So we want to put on the label. And third is some of the values, some of the configuration value of this indexing. For example, this indexing is unique or not. In that case, if you put a duplicate value, it will result in error. In our case, that's not the case. We want it to be false because we want to allow the duplicate value. And that's what all you need. It will just generate the indexing for you. Um, if we come here and refresh the UI, you notice that uh, kind of nothing is working. Basically, indexing is supposed to come here. If I come back and refresh the database, nothing happened. And the reason for that is this upgrade callback doesn't get called every time. If you remember the starting video, this upgrade get called only when you create a new database or you update the version. So we have two way to do that. Either we can delete the database, which we have been doing so far in the application. Second option is to upgrade the version. So let's try the second option this time. So we change the version, now it's 2, and this should be sufficient to kind of create the index. We just have one problem.
As soon we come to this upgrade, the IndexedDB will see that the store with the name to do store is already been created. So it's going to throw an error because it's a duplicate name. So we have to prevent that part somehow, and that one way to do is that you delete it. And that's normally what we do in the database mechanism, that when you change the structure of database or create an indexing, we normally kind of remove the table or kind of delete the table, and try to come up with some way to kind of uh, restore the data. In this case, such a not we don't have such a complex requirement, so we're just going to delete the database. And to do that, what you can do, a delete object store, and we can just put the name to do. Now this will do the job. What next thing we can do, for our case it's sufficient, but we can put one more check here, is that this callback give you something called old version as well as new version detail. So as a precaution, what we can do is we can put one check. If new version new version is not equal to old version, and then only when this condition is satisfied, then delete the store. So it's just put one check. You can also put like another kind of check, that if it is it's ahead of certain version, only if it is greater, then do those all those things. Those all are possible, but we just stick with uh, of this way. Now let's save it, and let's come back to the UI and see that if it is working. We can see that already we can see there is something called index label. Um, and since we kind of deleted our data table without restoring that data, all our data is gone, so that's fine, but at least our indexing is working. So let's see if we create those record again, 1 hash p0, 2 hash p1, 3 hash p1, and 4. Let's see what's the impact of it on our data. So this is fine, this is all working fine. This would be interesting to see that, how it's all working fine. So it's all on the label path, primary key, uh, and then there is we do have a label, right? Yes. Let's refresh it. Yes, now it's showing. Okay, I forgot to refresh the data. Refresh, click on refresh button, but we can see that indexing is now created, and it's kind of almost similar to the way we explain the whole part in earlier part. It's just in the display purpose, it just create a two entry, but ultimately this is how the whole indexing mapping work. So we are good till here. Now we managed to create indexing as well as the whole priority part of it. Next, what we're going to do is we're going to find uh, a way to kind of do some kind of filtering on the priority. What we uh, First of all, what we have right now is just a to do, and there is no clear indication of the priority. So let's fix that as well. And we're also going to do some kind of filtering logic in here. If you click on it, it will just kind of filter down all those to do with that priority. So let's kind of work on that. First, let's fix the priority. We want to show the priority label here in next to the to do. So let's fix that part. Let's go to do item, and we are here. We already have ID, text, and completed. What we need here is basically a label. And what we're going to say is if the label is there, and let's put it here, if my label is there, in that case I want to render it a span, and inside that there will be a label, right? So this will display it. Let's put some class name as well. We're going to style it a little bit, label. Let's first see that if it is showing on the UI. So nice. So P0, P1, P1, and there is no label here. Those all are coming. Let's style it a bit quickly before we move to the next part. So let's come here. So label, what we want is some kind of background color. Light gray would do. Light gray, and we want maybe a font style. Let's make it italic, so look a little bit italic way. Um, this will do. Anything, let's come here. Okay, so this is fine. We can just put a little bit of padding. So let's put a little bit of 0.4 rem on the horizontal side, and point 0.2 maybe on the top. And while we are here, what we can do, we can just say border radius to be 0.5 rem. This will do a little bit of rounding thing. Nice. I guess a little bit more rounding will do. Let's put 1 rem. This is nice. So we have uh, all our to do as well as its priority. Um, I guess text is a little bit small. Could be a little bit smaller. So I can come here. I can have it small. Yeah, that seems like now perfect. Cool. Now next job is like we are showing the priority. Now let's try to list it down here at the top so that we can use some kind of filtering. So to do that, what we can do, we can create one more component. We're going to call it to do um, labels. Let's create a component RSM, and we know that we're going to get the labels. So let's put it here. And all we want is when that happen, let's map it over it. Label, and a simple span will do. Yes. Right. So it's asking for key props. Okay, no problem. So ultimately we're going to pass a unique label. So it's fine. We can put it here. Not like this, because it was a unique value. So that will do the job of it. Actually, we want it to be clickable, right? So because on that we want some kind of filtering. So in place of span, let's use button, and let's see how it looks like. Okay, we have not included it, so let's do that part in to do app. So to do labels, and we want the whole labels part to be passed inside of it. So for that, what we can do, we can have um, labels property, and we can say set labels equal to use state, right? But how are you going to get the labels? So what exactly we want is, as you load, like as soon every time basically a to-do get added, we want to reload and we want to pull all the labels uniquely kind of index with the IndexedDB indexing. So one way to do that is, we can have a use effect like this and have to-do's length here. In that case, every time a to-do length changes, this whole method will get called. And in place of to-dos, we can have labels and set labels. And in place of get all, what we want is something like get labels. And this is the method which we're going to implement next. This will be under our to-do DAO and it's going to talk to our IndexedDB. So let's put this method here, just like all other methods what we have put together. And in this case, let's have we will need a to-do store and we will need in the read mode. So let's put this much. What we want here is basically the unique value of all the indexing. And in this case, there is no clear method exposed from the indexing that give me all the keys. There's something called get all keys, but that give you actually the indexing value the object is referencing to. So that doesn't give you the direct unique values. So one way to do that is basically you open the cursor on the indexing. So you can say here that index, and we can put the name of indexing what we have put it like idx underscore labels, and in the once we have the indexing in place, what we can say is something like open key cursor, and the first value of open key cursor actually takes some query that what is the limit you want to put for the query in the primary key terms. Since we don't have such requirement, we want to kind of query over the all the data we have in IndexedDB, we're just going to put it null. But the second one is very interesting. So second thing is like we only want to kind of iterate over the unique value. So we have something called next unique, which we're going to use it. But for now, let's leave it here as it is. We'll come to that later just to see like how it's change the behavior. For now, we'll just continue on our code and try to get all the duplicates label as well. If I put it here, um, yeah. So this is basically going to return um, cursor. And what we want to basically do is we want to iterate over that cursor. And one way to do that is you just put a while loop on the cursor and just keep on kind of continuing on the cursor. So basically you can do await uh, cursor dot continue. Now in case this will basically going to return, or it's going to return you the cursor value itself. So how this work is, you start with it kind of, if the whole thing is done, and actually we need a wait here because everything is asynchronous in IndexedDB. Once you get once you run this command, it's going to provide you the first cursor on the first data, first row basically, and every time you do a continue, it will keep moving to the next value. If you have the next value, the next cursor will point to that value, or otherwise it will be a null. In case if it is null, this whole while loop will be broken, and we can clearly return our labels. Right, return labels, right, and that will do the job. One thing what we want to do it while we are iterating it, we want to kind of store this cursor value into our array. So we can say labels dot push, and in this we can have cursor dot key, and in that case all the unique key will be kind of get stored and get pushed here, right? And this cursor is need to be let. All right, so this seems like kind of all done. With the current code, we should be able to get all the keys, including the duplicates one. So let's see if this really kind of working for us. So we go to this one, get labels is already there. So we have the labels here, and let's take this label and pass it down to our to-do label so that it can iterate over it and show on the UI. Let's see if this is working. We have some error here, cannot read properties of undefined. That makes sense because in the first case it will be undefined, so let's put that check labels and this thing. And nowadays the better way to check that is to check the array is array dot is array. So let's put that and keep our code a little bit modern. All right, so I can see that it's showing at the top. We wanted to at the bottom, so let's put it here. Right, and it's just showing the 0 for some reason. Let me just quickly debug it to do do. And so we have OpenDB to do store. This is fine. To do store transaction. This seems all fine. IDX label. This seems fine. Is this a problem? Oh my bad. I put the IDX label here. Here the labels. So that. Now let's see if this is working. So if I come back, yes, definitely is working. P0, P1 is what we're getting. Uh, yeah, a little bit ugly right now. So let's quickly put the little bit of styling here. To do item, to do labels, yes. And come to, let's put it here, class name. We're going to call it to do labels. And inside of this, let's go to index CSS. First thing what we want is to be displayed as flex, and then justify content, and we want it to be flex start, maybe a little bit of gap, so I just put it 1 rem for now. That will do. And second thing we want is a little bit different button. So on button what we can say, that border none, we don't need that. Background will do, that's fine. And we can have cursor equal to cursor pointer. Let's see where we are. Fine. Okay, a little bit of margin. Top we want around 1 rem. Side 0 will do. Nice. Seems kind of all working fine. So this will kind of going to do a kind of filtering with the P0. One thing also we want is basically when it's all done, we want to be clearing it also. So there is some functionality we can use to clear it. So after this mapping or this rendering all those labels, let's have one more button, and we will use it to clear the label filtering, and we're going to call it class name clear. And while we are here, let's come back, put border none will do. Cursor point is what we need. This is already there. We want a background none. All right, so this is like nice in the side, without in background. And one thing we want to do is basically take it to the rightmost so that it just kind of doesn't come with the rest of the labels. So maybe clear this could be here. One very simple simple way to do that is to achieve that is like just put the a margin left and just put auto. In that case, it will just move on the right side. Perfect. Right, so seems like it's all on the UI part is working fine. What we're going to do next is we're going to have some kind of callback here. So to do app. Now what we don't want is basically this, whenever we load all these to-dos, we should be able to do some kind of filtering depending on this label what we pass. So let's have a state variable to store that part. We're going to call it like active label, set active label, and this will be use state. To keep things simple, we can just pass this directly to to-do's label and just try to set it from there. Other ways, like you keep it separate. You have some kind of dedicated on click handler, and then you set it here. Um, Both are fine. We can just, to keep things simple, we just pass the um, setter directly here. And whenever somebody click on this button, we want to pass this label. So we say on click set label, and we're going to pass the label value inside of it. We want same behavior here as well, but in place of passing label, we're going to pass it null, right? And then uh, this value, whatever label we have it, active label, we want to pass it as some kind of filtering. So on this get all, I'm going to pass something called filter, and in that, uh, or this will be whole thing will be a filter, and we're going to pass as a property called label. Same thing, we have one more get all here. This is fine. But we want to do this thing every time a to-do get added, right? We want to, whenever that get added, we just want to filter it out so that it's all sync with the IndexedDB. So what we can do, we can just put this value here as well. And actually, whenever the actual active label just change, only then we want to kind of the latest data. So I guess just putting the active label will do, right? So whenever you create a label, it will just do it. Yeah, I guess it will do it. Otherwise, we'll come back to kind of correct it. So active label is fine. I guess this all are done. Now the main challenging part left here is to come inside of it and try to modify get all. Right now what get all does it like it just pull all the data from IndexedDB with no regard to the filtering logic. So we're going to change that part. We're just going to have a something called filter, and in case if it is filter is present and we have this filter label as well, we want to work differently. And that's where the second part of the of indexing come into picture, where we already have indexing put on the label, so we're just going to utilize that. So what we want to do is basically we want to say return. We already have a store, so in store get the index, and let's put the name right this time. And with this indexing, right, get me all the data, whatever you have it for this label. All right, I guess this will do, right? Just let's understand this one more time. Basically, this what we exactly saying that whenever I select P0, you get all data which is corresponding to P0. In that case, this data will come. When I pass P1, get me all the data corresponding to P1 indexing, that is the record 2 and 3. And that's basically what we're trying to say here, right? Let's see, like, if this work. But before we move further, there's a one thing I just noticed that something we have to fix it, which we left it. If you remember, we talk about it that if you don't put the right configuration, we go get the duplicate label value, and that's what we are seeing here. We're getting the P0, P1, and P1, which is for these two to-dos. Now this one is very easy to fix it. There's a one configuration we have to provide, and we have to go to to-do DAO for that. In the open key cursor, we left kind of the second argument previously, but now we can provide that one, and that what we want is the next unique.
Now this will make sure that the jump between the cursor happened only to the unique value, and that will solve our problem. And you can see already there is a only P0 and P1. If I click now on the P0, only the P0 is coming. P1, now 2 and 3 is coming, clear, and all 4 are coming. Perfect. So this seems very nice. We can do a little bit of styling, fix it quickly, and that will finish our job. If I go back to To Do app, what I can do, this active label, I can pass it to our label component here, and just have a little bit of different styling in case active label is there. So what we can do, active label, um, in case here, I guess we can put it class, and in case active label equal to label, that is on which we are iterating, then we want a button class active. Otherwise, we just empty string will do it. All right, so let's now quickly put the styling for this. So we already have this. Let's copy the whole part. To do on active label, what we want is basically background to be light blue will do, and this is not needed. Can we check it now? P0 perfect, P1 perfect. Once we clear it up, it's all been clear. All right, so this is like basically what I wanted to cover. Seems like our filtering logic is all working fine, and we have utilized the cursor logic, the indexing logic together, and make it's all working fine. No complex UI filtering logic or anything like that. It's all the power of IndexedDB, that's what we are using it. So I just stop here. Let's talk a new topic in the next video. So we have covered a lot of functionality of IndexedDB in this tutorial. We started with a simple to-do application. We added a functionality to add to-do in IndexedDB, then to get it. Then we have introduced the other CRUD operation like delete and update. Thereafter, we utilize the concept of cursor and indexing to kind of put the filter together. And this is like kind of almost I wanted to cover in the IndexedDB part of it, and we are kind of good on the IndexedDB concept. This last video I want to kind of dedicate on the IDB and try to use some of the improvement IDB done over the IndexedDB API, which can kind of solve our or kind of ease our life a little bit further. Um, so IDB kind of based on the some of the assumption try to improve certain APIs. For example, if you say this code, right, the add part of it, you will notice that we are working on only one store, but then we are repeating this name on multiple places. That is one here, and we have one here. And since it is the add operation, isn't like understood that it will be a write operation. Do we really need to provide it? And on those assumption, IDB kind of created a few helper APIs which can minimize the number of line of code. So what I'm going to do is I'm going to kind of clean this whole code and try to use those improvements. So first what we want to do is basically want to get to do key. So to do that, what we can do in place of going and doing the transaction and finding the object store, I can clearly say or I can directly say db.add, and it will let me add the value in the store, and the first argument it takes is the store on which you want to add it. Second is the value, and that's it. It just kind of take every other part of it as with the assumption that you're working on only on one store on which you need a transaction, as well as you're trying to fetch the value from it, as well as since it's an add, it will be a transaction right.
So once we have the to do key, now what we can do, we can just return it and get the value directly from the uh, using the DB API. So I can say db dot get, and in the same way I can put the store name first and to do key as next. Let's see that if add is working fine. So refresh it. 4. I'm just going to create 5. All right, 6, and with the priority P3. Perfect. It's all working fine. Let's put the same concept on some other method. So I'm just going to pick one more, maybe a delete one, right? We can work exactly in the same way. Let's kind of comment this code and put the return db dot delete and put the store name first value and then the ID as the second, and that will do the magic. Refresh it. Let's try to delete this guy. Working fine. 4. Refresh it. All working fine. Go to another tab. All working fine. Filter is all good. Clear. Everything working fine. Alright, so that's all what basically I wanted to cover in this long tutorial. I hope you will like it. In case you have any question, suggestion, just please comment on the below the video. And if you like the video, please give a thumbs up and subscribe to the channel. Thank you.